So where is f of x greater than e of x? Where is our graph bigger than that? That's what we're trying to figure out. So in order to see that, we need to graph this other thing. I got to graph e of x at the same time that I'm doing the other. Okay, so I'm going to go to y equals, and I'm going to put into y2 this second equation. I've got my first equation. We got our picture. Now we're going to graph e to the x power. So second natural log. Okay, so it's down here. There's your e to the x. ln is natural log. We're doing e to the x. And I need x. So it should look like that. And I'm going to hit graph. So we already had the one wave. That was our original graph. And then the e to the x is that little line going off the graph paper there. Question so far? So let's look and see what the question said. Where is our graph above or greater than the other one? That's what it's asking. So what part of the graph is that true? Right now, here in the beginning. So here in the beginning, here's our graph. Right now, is it above it? Tell me when I stop being above the other graph. Right there. Right? So from the beginning until right there. So at the beginning, well, that would be starting at 0 until right there. What happens when we say right there? They're intersecting. The two lines are crossing. So I need to find out what x value are they crossing. Okay, so to find an intersection point, we're going to go second calc, our favorite menu. Go down to 5 for intersect. And this one's a little bit different. We're not going to the left and right anymore. We're going to move our cursor to where we think they intersect. Okay, so I'm going to move my cursor. I can't put in a guess number anymore, so I get to pound on my screen for a minute. But I'm going to move that cursor to about as close as I can get to where they two lines cross. Okay, if it's off a little bit, you're okay, but you want to be as close as you can. And when I think I'm on top of where they cross, I hit enter. And then it will ask you, where does the second line cross? Well, it should be in the same spot. Your cursor might be off a touch, and you might have to remove it a little bit. Remove it. Move it a little bit, not remove. But I'm on it again, so I'm going to hit enter, and then it's going to tell me guess, and I'm going to hit enter a third time. Really, you just got to get it on top of it and hit enter 3 times, and it'll get you what you want. So it tells me my x crosses at 1.861. Do I need that number here? Do I? Where's my graph bigger than that? Yeah, that's what I want. I want to go from 0 to 1.861. That's when my graph value is bigger than the other one. At 0, is my graph actually above e to the x? Right there, am I above e to the x? Since it's above, what should I use? Bracket. It is greater than. Bracket. 1.861. The thumbs up if you think it should be a bracket. Thumbs down if you think it should be a parenthesis. Up for a bracket. Oh, lots of thumbs down. Lots of parentheses. Why am I going to use a parenthesis on 1.861? Chelsea, what'd you say? It's not higher. It's not above the other graph. What is it? It's the same. So I don't want to say that it's above there. If I put a bracket, that's a lie. It's not above there. It's the same. That's why I use the parenthesis at that point. Make sense on that? Intersection points. So number 8, we're doing the same type of thing, but a little bit different. Okay, so number 8, it says, find the intersection point of that graph and this one this time. So my same f of x from up above, the cosine sine one, but now in that equation. So I'm going to go to y equals, and I can now change that second equation. I don't want e to the x anymore. Now I want this thing. So 8 minus x squared plus 6 natural log, that's ln here on the left side, natural log, 3x minus 1. Close my parentheses. We good? We graph it. It's going to graph both of them since I changed one of the equations that was graphed. It goes back from the beginning and graphs it all over again. Kind of silly, but it does. we are trying to find the intersection points. Show me with your fingers. How many times do my graphs cross? 2 times. I've got one here in the beginning and one right there. So I need to find those 2 points. Okay, I'll show you how to do the first one, and then we'll go to the second. It says not only are we finding them, we're going to store their answers. So it's like what we did last time, but a little bit different. So second, calculate, intersect. So 5. Second, calculate, intersect. And then I'm moving my cursor to that first place. Lots of fun. On your calculators, you can hold it down. My screen just doesn't let me hold it down, so I get to bang on the button. Until it's right about on top of it, I hit enter. On first curve, it says second curve. I hit enter again. It says guess. I hit enter again. And it'll tell me it crosses at the intersection point of x is equal to 0.565. So I'm going to write down x is equal to 0.565. That is an answer. Okay? But it says, okay, now we're going to take that answer and store it in our calculator. What we just did when we wrote down 0.565, we rounded it. It's not the same number anymore. But sometimes a problem asks you to take that number and use the whole thing. Don't round it until the very end, they'll say. You can't round to the end because otherwise it changes the answer. So we want to be able to have this number ready to use but not have to type in 0.56523977777, whatever. Okay, so we're going to store that answer. So here's how we do that. Second, so once I have x is equal to, I'm going to hit second quit, and it's going to go back to my regular screen. As long as you just had that answer still up, as long as it still says x equals to on your graphing screen before we quit, now we can use this store button down here. This STO arrow button down here on the left side. Right here. I'm going to hit that button, and it should say your answer is going to be arrows stored as something. And now I'm going to store it so I can use it later. So I'm going to store it as the capital letter A. So I'm going to use alpha A. So I hit alpha and then the math button. Here's alpha, here's A. I stored it as A. So what it does is it takes your answer that we just got and it's going to save it as A. Okay? Isn't that the same decimal we just used? So now later if it says take 3 times your last answer, I could do 3 alpha A and then it does 3 times my last answer and I don't have to type it back in. It just saves it for you. Does that make sense? Yes, ma'am? Okay, you probably did something in between there. We'll check it out here in a second. Questions? Try and find B now on your own. Okay? So now you're going to go back to our graphing screen. You're going to find the other intersection point. And then once you've got it listed, hit second quit and try to store it as the letter B. Go. So once I find that intersection point, then we're going to hit second quit. Second quit. I'm going to store, so I use the store button, that answer as alpha B. So the letter B. Okay, now every time I use B, it's going to give me that answer, which was 5.265. Good there? Last thing we're going to learn with this. On the next one, it says find f of A. So what does that mean? Finding f of A, what are we trying to do? Plug that last answer we had into our equation. Well, look at our equation. Our equation is this big old giant mess. Do we want to type in cosine of 0.565, blah, 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 and then minus 5 sine, blah, blah? That's going to take forever, right? So we're going to use our calculator to do that shorter. So here's what we're going to do. If you've typed your equation in already once to graph it, now it's already saved as y1. Okay, so right now it's saved under y. See how it's saved as y1? It's stored as y1, so we're going to use that to our advantage. So we're going to, in order to pick that up, we're going to use the vars key right here. Okay, here's the vars key, the VARS. We're going to hit that button. And we're going to move our menu over to y vars. And then enter on function. We're going to pick that it's a function graph. It's a regular graph. And what was our equation stored as? y1. So we're going to hit enter on y1. So it's saying using the function y1, which is what we have it saved as right now, what do we want to plug in? A, 0.565. So I'm going to go parentheses, and I'm going to type in A. Alpha A. There it is. Close the parentheses. When I plug in A, I get 5.504. 5.504. What if I plugged in, I have two equations saved, right? Let's plug in the second one. So I can do the same thing, vars, y vars. Now let's use y2. Same idea though, plugging in A. Makes sense? Now I'm just plugging it into the other one, the other equation. I hit, oh no. I got the same answer. That's weird. Why'd I get the same answer there? It's the intersection point. It's where the two graphs crossed. When you plug in the same x value, you're going to get the same y value because you're talking about the same point. Does that make sense how that works? Do the second part there.